Hello everyone, happy Wednesday. This is now our sixth instructional video. I am totally amazed that we've made it this far. Hopefully you guys are doing well, that you guys are kind of getting the hang of doing online work. I think most of you guys are doing great. Shout out to those who have turned in their assignments. Today we are starting a new concept. By now you should have finished mini QPA 1 and 2. If you have not completed those, please come and email me, message me, contact me. I can get on the phone with you to help you work through those problems. Look forward to a misconceptions video. By this point, I should have posted it already. There was some confusion about the questions, etc., and I want to make sure you guys understand what you're doing. Anything else? Live sessions Tuesdays and Thursdays, 9:30 to 11:30. I'm gonna try Google Hangout, so please join. I would love to talk to you in person. I'll also have YouTube live streaming on in case Google Hangouts does not work for you. And other than that, I think that's it. If you guys want to see, this is my living room. I got some nice windows for you guys in the background. Hopefully you guys also have some time to go out and enjoy the weather, practicing safe social distancing, of course, but alas, let's get started. So either have your packet with you or be following with me on your computer. And let's just share my screen. Okay. All right, let us begin. So, I also, wait, another side note, I do want to get some feedback. I know I'm doing my videos a certain type of way, but I'm wondering if something else might be more helpful. If you guys have any feedback for me, please comment below on like what has been working for you and what hasn't been. And if there's something another teacher is doing that is super helpful, and it'll be really cool if I did that too. Okay, so comment below. All right, so today's objective, we are going to be now creating a best fit line to model data on a scatter plot. So we've talked about independent dependent variables. We talked about trend. We talked about the strength of a scatter plot. We talked about how to make a relation, like how to talk about the relationship of a scatter plot. Now we're going to actually make some predictions, okay? And this is where we're going to combine graphing with algebra. The reason why is because with data, right, there is no such thing as perfect data. When you are dealing with humans and just life in general, there's no such thing as perfect data, but our job as mathematicians, as people interested in supporting our arguments with mathematical evidence, the goal is this: we want to make our best educated guess. And the way to do that is to have mathematical models. And in this case, we're going to work with a linear model. All right. So this is the main question for today. How do you use observed data to predict unobserved data? So I'm talking about data that we collect to figure out data we haven't collected yet. Because there's a lot of times where we can't collect all the data we want, but we kind of collect what we can, and then we make the most educated, best guess. And that way we can make predictions. And predictions means being able to guess what's going to happen in the future. Or yeah, basically being able to guess well, right? So we are going to be investigators trying to guess. So how do we use observed data to predict unobserved data? We can use a best fit line to make predictions based on our scatter plot. Excellent. So you are going to use something called a best fit line. So when we're talking about a best fit line, we're talking a line that best fits the data, okay? Best fit. Think about your favorite outfit, how it fits the best on you. That's what we're talking about. We're trying to find a linear model that best fits our data so we can make a good guess based on a general trend that we found out, okay? My computer is really shaky today, my apologies. So there's a couple of examples. So we have our scatter plots, right here. We have our many data points, right? You see all our data points right there. And we notice that there is a line cutting through the middle of all this data. Okay, this is our best fit line. Best fit line. Okay. It is a linear model. Linear model that helps us make educated guesses. Once again, just a reminder, if I'm writing in red, you don't have to copy this down. If I'm writing in blue, you do want to copy it down. So I made a mistake. This should have been in blue. And then we just rewrite that. What a waste of time. I'm sorry, y'all. So what did we say? We say we can use the best fit line to make predictions based on our scatter plot. Yeah, so if you haven't typed that down or took notes on it somewhere, you want to write that down. How do we use observed data to predict unobserved data? We can use the best fit line to make predictions based on our scatter plot. Okay, so let's move on to the next page. All right, so a couple of things. I want you guys to think of 3 things when you think about your best fit line. I have it written down here. A line of best fit should be drawn through the middle of the data points. It should have an equal number of data points on either side, as equal as possible. And it should follow the trend of the scatter plot. So what does that mean? All right, so we're going to answer this question here together. Which scatter plot has the most accurate best fit line? So we have 4 scatter plots here. It's about time watching TV versus your grades, okay? I want you to pause this video and take a guess. Which graph do you think has the best fit line? Which line best captures the data of the scatter plot that we're looking at? So if you note, we have one best fit line like this, one best fit line like that, one like that, and another one like that. Okay, find a line that is drawn through the middle of the data points, has an equal number of points on either side, and follows the trend of the scatter plot. So pause your video. Is it A, B, C, or D? Think about the answer. You have your answer in your head? Okay, good. So the correct answer is this. The correct answer is gonna be C. So if you got that right, give yourself a pat on the back. If you didn't get that right, that's totally okay. Give yourself a pat on the back for trying, right? I'm gonna tell you now why the other ones are wrong, okay? So if we look at D, so I'm gonna be writing in this blue, so you should follow along with me. If you have it online on the computer, you don't have to follow along, just make sure you're listening to me. So let's look at D. Why is this wrong? D is wrong for various reasons, okay? Is it drawn through the middle of the data points? Kind of, right? You kind of drew it like if you were to define middle as like you cut it in half, then yeah, I guess you did cut the data points in half, because number 2, right, we have 1, 2, 3, 4, 5 data points on the top, and you have 4 data points on the bottom. That's kind of equal, right? So you're like, okay, like that kind of makes sense. But number 3, does it follow the trend? If you look at the data points, right? Let's look at our data points here. This is our data points, right? You see those? What kind of trend is it? Is it positive? Is it negative? Or is it no correlation? It's actually negative. So we want to find a line that has a negative trend, a negative slope. So this one is wrong. Is wrong because it doesn't follow the trend. It doesn't follow the negative trend. Okay? Using this logic, what's another one that's wrong? Think about it. Which other graph is completely wrong? It has to be A, right? Because this one, oh wait, why did I circle that? What the? A is totally wrong because guess what? This line doesn't follow the negative trend. So if that's the case, why is B wrong? B is negative, the line is negative, right? But why is it wrong? This is where we have to look at number 2. We want an equal number of data points on either side. So if you notice here, right? This is our data points, right? All 1, 2, 3, 4, 5, 6, 7, 8, all 8 of them are underneath. Did I count that right? 1, 2, 3, 4, 5, 6, 7, 8. Excuse me. There should be 9. So all 9 of them are underneath the line. So on this side, is there any data points? No. So it's not equally balanced, right? So you want to find a graph where you have equal number of points on either side. So that's why this one is perfect, because in this case, it cuts right through the middle, hot dog style. Okay, you want to make sure it the line travels with the data points. There's 1, 2, 3, 4 at the bottom, and then 1, 2, 3, 4 at the top. So it's equal number, and it follows the trend. It's negative. Okay, that's why in this case, our C is our correct answer. Okay. So in this case, drawing a line of best fit is a lot of practice, and I know previous years when I taught this, it was kind of confusing, right? The way I like to think about it is that imagine if, think of it as a hallway, every data point is a hallway of people, and you're the person just cutting through all of them down this hallway, right? That's the way I want to think about it. And it comes with practice, right? So why don't we move on to the next page? Let's look at page 3. I actually would highly, 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 highly suggest, oh wait, where'd the graph for this one go? That's okay. I don't know where this graph went. Missing graph. Hopefully you guys can see it online. Anyways, I would highly, highly suggest clicking on these links because these are gonna really help you figure out how to draw a line of best fit. Okay, the first one is just doing it on the computer. The second one is actually a Naruto game, so this is for my anime lovers out there. Try this out. It's actually, even if you don't watch anime, this is actually really helpful for you to figure out what a line of best fit looks like. It's actually very, very, very accurate. So I would highly suggest you check this link out. And then there's Khan Academy, which is a little bit more confusing. No, it's not confusing, but it has videos and a little bit more complex, and I actually think if you want to challenge yourself, you should click on that link. I will go over number 1 with you just so that you guys have an idea of what I'm looking for, and then we're going to wrap this video up. Okay, so let's look back at number 2. So our goal is to identify whether the scatter plot has a correct or wrong line of best fit. So if I look at number 1, right, here are my data points, and here is my line of best fit. I need to ask myself 3 questions, all right? 1, is it in the middle? 2, are there equal data points on both sides? And what's my 3rd question, right? Does it follow the trend? All right, number 1, is it in the middle? Yes, it is in the middle. Number 2, are there equal data points on both sides? So if I look at this, I see 1, 2, 3, 4, 5, 6-ish on the left, and then 1, 2, 3, 4, 5-ish on the right. Equal number, fairly equal in number? And does it follow the trend? The data points have a negative correlation, and my best line of best fit line has a negative slope. So it does indeed is correct. So I would write down for number 1, correct. Okay. So that's what you have to do. Then the next page, I ask you again, A, B, C, or D, which one has the best or the correct best fit line? Write the letter in the box below. Number 4 is a little bit about using the line to make a prediction. And this is your exit ticket. I want you to explain why it's correct or wrong using the 3 steps that we talked about. But before I end this, I actually remembered a really key point that I want you guys to understand. And you guys should write this down somewhere. Let's write it down here. So everyone go back to your notes, your second page. Okay, we're gonna write this. I need you guys to write this down. This is super, super important. I'm gonna do that, okay? The line, the best fit line does not have to cross the data points. Okay? You do not need to like connect the dots or like draw the line so it goes through a couple of dots. Like think of it as like 2 separate things, but the line is influenced by the data points. Yes. If you guys have any questions, please let me know. I wish I could be there in person with you. If you do have questions, please come to my live stream so I can kind of go over it with you. So this is actually what you need to do next to do. Okay, do your practice problems and exit ticket. Try out those links to turn in your work into Google Classroom, or email me, please. I know a lot of you are doing paperwork, but I do want to see your work so I can give you feedback. 3, comment below with any feedback. Okay. What am I doing well? What am I doing wrong? Please let me know. I will also include some other resources. There are a lot of things out there around the best fit line that might be really helpful. So please check those out. If you have any questions, I keep saying this, please contact me. I am available. I am free from 8 to 5 p.m., 8 a.m. to 5 p.m. So hit me up. Like, I want to be as helpful as I can. And though while there are some of you doing your work, there is a large amount of you who are not. And I want you guys to be on track of things. Okay, be safe. Hopefully you guys are doing well. Yeah, hopefully math was impossibly easy, and have a great day.